Welcome to Pre-Math. In this video, we have got this green square DEFG fully confined in a right triangle ABC, as you can see in this diagram, such that this side length AB of this right triangle is 4 units, and the area of this triangle ABC has been given to us as 24 square units. And moreover, these points of the green square D, E, and F lie on this triangle ABC. And now our task is to calculate the area of this green shaded square DEFG. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. Before we proceed any further, let me go over the basic concept review. And now let's focus on this square. As you can see over here, we can see all its angles are 90 degrees each. And this is the diagonal of this square, represented by lowercase d. And moreover, this diagonal makes an angle of 45 degrees over here and 45 degrees over here as well. And likewise, this angle is going to be 45 degrees and this is 45 degrees as well. And if we draw another diagonal of the same square, then this diagonal is going to be equal to this diagonal. So this diagonal length is going to be lowercase d as well. And furthermore, these two diagonals are perpendicular bisectors of each other. In other words, this angle between these two diagonals is going to be 90 degrees, and this segment is going to be equal to this segment. That means these two segments are equal, and likewise these two other segments are going to be equal as well. And the length of all these four segments is going to be same. And furthermore, the area of this square is going to be equal to d square divided by 2, where d is the diagonal length. And if I drop this perpendicular EF, then we can see that this EF is the diagonal of this green shaded square. And now our task is going to be find the length of this diagonal EF before we could calculate the area of this green square. And here's our next step. Let's focus on this right triangle ABC, whose this side length is 4 units, and the area has been given to us as 24. And now we are going to calculate this base of this right triangle BC. Let's recall the area of a triangle formula. Area equals to a half times base times height, where our height is 4, our area is 24, and we are going to calculate this base. So let's go ahead and fill in the blanks in this formula. Area is 24 equals to a half times base, I'm going to call lowercase b, times height is 4. So therefore we got 24 equals to 2 times b. Let's divide both sides by 2. So therefore our base b turns out to be 12. So thus our this base BC length turns out to be 12 units. And here's our next step. Let's focus on these two right triangles. This smaller right triangle FEC and this bigger right triangle ABC. So therefore we can see that this right triangle FEC is similar to this right triangle ABC according to angle similarity theorem. And we can see that this angle is 90 degrees. Likewise, this angle is 90 degrees as well. And this angle is common to both of these right triangles. So therefore, we are going to have a proportion. In other words, the ratio of FE and EC. Let me write down the ratio of FE divided by EC is going to be equal to the ratio of AB length divided by BC. And now we can see our AB length is 4 and our BC length is 12. So therefore we can write FE divided by EC is going to be equal to 4 divided by 12. And here I'm going to reduce these one a little bit. I'm going to put it 4 over 12 could be written as 2 over 6. I am not going to reduce it all the way to 1/3 as you can see in this next step. So we can see that this ratio equals to this ratio. So therefore we can write this one as FE length is going to be equal to 2 times some constant k, and EC length is going to be 6 times some constant k. And now our task is to find the value of constant k. So therefore our this EC length turns out to be 6 times k, and this FE length turns out to be 2 times k. And here's our next step. I have drawn this diagonal DG as you can see over here. And now let's recall once again the diagonals of the square are perpendicular bisector of each other. So that means these two diagonals are going to bisect at this 90 degrees. And furthermore, this segment is going to be equal to this segment, and this is going to be equal to this segment, likewise equal to this segment. And if P is the point at which these diagonals intersect each other, and we know that this diagonal EF is 2k, then this diagonal DG is going to be 2 times k as well. Therefore, the length DP is going to be 1 times k, the half of that one, and this length is going to be 1 times k as well. And now let's make an observation. We can see that this segment DP is going to be equal to this segment BE. If this segment is 1k, then this segment BE is going to be 1k as well. So therefore we can see that this whole length BC turns out to be 1k plus 6k is going to make 7k. And we also know that this BC length is 12. So therefore I can equate 7k equals to 12. So therefore we are ended up with this equation 7k equals to 12. Let's divide both sides by 7 to isolate k. So therefore our k value turns out to be 12 divided by 7. And we know that the diagonal length of this green square is 2k, which is right over here. And our k value is 12 divided by 7. So I'm going to replace k by 12 divided by 7 over here. So therefore this diagonal length is going to become 2 times 12 divided by 7, means that is going to give us 24 divided by 7. And now let's recall the area of a square formula. Area equals to d squared divided by 2. And in our case, our diagonal length d value is 24 divided by 7. So therefore I can write this one as 1 divided by 2 outside and times 24 divided by 7 whole square. And we know 24 divided by 7 square is 576 divided by 49. So therefore we can reduce this one and could be written as 288 divided by 49 square units, the area of this green square. So thus the area of this green square turns out to be 288 divided by 49 square units. And that could be also written as equal to 5.88 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.